Hi guys, there are a couple of questions from section 4.5. The first one is number 3. So this section is of course integration by substitution. So basically what you want to do is you want to choose the right substitution so you can be able to basically integrate, okay? So this is a technique we call integration by substitution. So this is why we have the u, as u comes in place of the x, so we are substituting basically the u, which is the reason why they call this integration by substitution. Anyway, so we have our integral of the function x squared minus 6 all raised to the 7th power times x dx, okay? So the first thing, of course, I noticed, I'm sure you read the section carefully, so there is a rule that basically says that if you have integral of u, so u could be any function, so again, we're about to choose our u here in this case, but u could be any function, raised to the power, and n could be any number, any exponent, times d not, this is where you have to be careful, times du, right, not dx. So our original d is dx, but we're going to have to, of course, if we're going to use the formula, we need to get the du, which I'll show you in a minute how we get that. But anyway, so this formula, which is what they call the power basically rule, that says that that integral of any function to the power, any power, times the differential of that function is the same thing as the function to the power plus 1 over the power plus 1 plus c. This is almost like the one we had for x to the n, except this is more general because now you have any function to a power. So as you can see here, we have a function to a power. So we're going to try to use this formula. So the first question, of course, is what is our u, right? So u is going to be the function that is being raised to a power. So in this case, this is the only function that is being raised to a power. So we're going to let u be exactly that. So here's the question. If u is that, then what is du? So if you remember, du, this differential of u is just a derivative of this times dx. Therefore, derivative of x squared, of course, is 2x. And then the derivative of, of course, derivative of 6 is 0 because that's constant. But don't forget times dx. So this is the formula. The differential of u is always derivative of the function u. In this case, our function u is this times dx, which becomes 2x dx. So if you notice very carefully here, we have x dx. So here's the good news. So the variable part matches, which means we can go ahead and put du, except we don't have a 2 here. So we're going to remove this 2 by dividing both sides by 2. So we can have an exact match. So as you can see, the 2's cancel. So all you get is x dx, right? So now we have x dx, the same as du over 2. So now we can go back up here and change everything to u and du. So I'm going to see if I can just kind of squeeze it right here. So therefore, the original integral becomes, well, remember, we call this u. This was our u, so we're going to replace that by u. Of course, power 7. And then x dx from here becomes same thing as du over 2. So it'll be times du over 2. So the only problem left is, of course, we need to remove the 2 outside because here the formula says u to a power du. So we don't have the 2. So we need to move that, okay? So let me go ahead and bring, as you know, any constant can come outside the integral. So we're going to go ahead and bring the 2 outside. So from here, we have the same thing as 1/2. So that 2 from downstairs comes outside. Integral of u to the 7 du. So now you can use the formula that says integral of u to any power. In this case, our power is 7. Is u to that power plus 1. Of course, 7 plus 1 becomes 8. Over the same number, 8, and then plus c. The only thing left to do is, of course, we always have to go back to the original variable. Remember, u, of course, we created the u, which was the function x squared minus 6. So we have to go back and put that in place of it. So the final answer is going to be x squared minus 6 raised to the 8th power over 8 plus c. Okay, so there is your integration by substitution technique in this case. And by the way, they do want you to check it by differentiation. So what that means, of course, is once you find your integral, to check to see if you did it correctly. Remember, integral is opposite of derivative, right? So if you differentiate this function, you have to get back to this same function, okay? And of course, it's obvious because as you differentiate this, remember, you have a function to a power. So by the extended power rule, this becomes 8. And then, of course, the 8 cancel each other. And then times 2x minus 6 over, oh, by the way, I'm sorry. I forgot the 1/2 here. Sorry about that. So this 1/2 is going to be times, of course, that, which becomes actually 16, 2 times 8. So anyway, if you differentiate that, so 8 comes down. And then, of course, you get times the function to a power minus 1, which is 7, times the derivative of the function, which is 2x. So the 2 and, of course, 16 make that, the 2 and the 2 downstairs cancel. Because remember, 8 and 16 leaves you with the 2 down here. And of course, all you're left with x dx, okay? Anyway, you can, I'm sure by now you know how to differentiate this. That's what they want you to check, right? So the derivative of this must be the same as that. If it's not, that means you did something wrong, okay? All right, I'll try to make a couple of more videos for a couple of more questions.